sum and difference formulas. This lesson will involve the following identities, the sum and difference identities. And you'll see in the formulas that there is 2 Greek letters that you might not know. The one that looks like the little fish is called an alpha, and the one that's a scrolly B is a beta. Another thing you might not have seen before is in the second formula, the one for cosine. After the parentheses, it says equals cosine alpha, cosine beta, and then there's an upside down minus plus. What that means is you put the opposite sign of what you started with. So in the parentheses, there will either be a plus or a minus, not both. If there's a plus in the parentheses, then later in the formula, we'll write a minus. And if there's a minus in the parentheses, later in the formula, we'll write a plus. So minus over plus means do the opposite. In the sign formula, it's plus minus both times. So that means whatever you start out with in the parentheses, you'll keep that same sign in the formula. The one for tangent has both. On top is plus minus, so you keep the sign you started with. On bottom is minus plus, so you'll do the opposite of what you started with. We'll also need the unit circle for these problems. So everything you see here should be jotted down or printed off or whatever so that you can have it in front of you while you look at the different examples. The first problems they give us are really just practice on how to use the formula. They're not really examples of what these formulas are actually used for. We'll get to that in the end. But now we're just getting used to the formula. And in the parentheses, we have 60 degrees minus 45 degrees. Always label the first angle as alpha and the second one as beta. And then we're just going to fill in the formula for sine of alpha plus minus beta. So that formula says sine of alpha, which is 60, cosine of beta, which is 45, and since it's plus minus next, that means I keep what I started with, which is a minus. There's a minus in the parentheses. I need to keep that. And then it goes cosine alpha, which is 60, sine beta, which is 45. Now go to the unit circle to look up all of the values for what we have in the formula. We want to know the sine of 60, the cosine of 45, and so on. So on the unit circle, remember that the first number in the parentheses is the cosine, the second number is the sine. Looking up the sine of 60, it is square root of 3 over 2. Cosine of 45, square root of 2 over 2. Cosine of 60 is 1/2. And the sine of 45 is square root of 2 over 2. Then we have fractions being multiplied, so you'll multiply tops and multiply bottoms. That would be square root of 6 over 4 minus square root of 2 over 4. You already have a common denominator, so you can put those fractions together. Square root of 6 minus square root of 2 all over 4. Cosine of 45 plus 30. So 45 would be the alpha, 30 would be the beta, and I'm using the cosine formula. That one goes cosine alpha, which is 45, cosine beta, which is 30, and then there's the minus over the plus. That means use the opposite sign of what we started with. Since there's a plus in the parentheses, we should use a minus. Sine of alpha, which is 45, sine of beta, which is 30. Now go to the unit circle, look up all those values. The cosine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2 minus sine of 45, square root of 2 over 2, sine of 30, 1/2. Multiply tops, multiply bottoms, square root of 6 over 4 minus square root of 2 over 4, square root of 6 minus square root of 2 all over 4. The answer for the sine and cosine problems are just a variation of this. There will be a square root of 6 somewhere, a square root of 2, a 4 on the bottom. Sometimes it's plus, sometimes it's minus, but it's just different variations of those same numbers. Tangent of pi over 3 plus pi over 4. So pi over 3 is the alpha, pi over 4 is the beta. The tangent formula has tangent alpha, which is pi over 3, and then a plus minus. That means keep what you started with. Tangent beta, which is pi over 4, over 1 minus, or actually it has a minus plus, so we do the opposite sign, which would be minus. 1 minus tangent alpha, tangent beta. Then look up those tangent values on the unit circle. The tangent of pi over 3 is the square root of 3, plus tangent of pi over 4 is 1, over 1 minus, and again square root of 3, this time times 1. So it's square root of 3 plus 1 over 1 minus the square root of 3. You could multiply top and bottom by the conjugate, 1 plus square root of 3, and get rid of that square root in the bottom. I'm just going to leave it like that. Now that we've had some practice using the formula, this is actually used for. The unit circle only has certain angles on them, but sometimes we need exact values of other angles that are not on the circle. Exact value means we're not putting in the calculator and getting a decimal that's being rounded. That's inexact. So 105 is not on the circle, but we can find two angles that are on the circle that either add or subtract to make 105. There's more than one correct answer to this, but if I look at the circle, I can see that 45 is on there and 65 is on there. Not 65, 60, sorry. 45 degrees is on the circle, 60 degrees is on the circle, and when you add them, you get 105. So I can break cosine of 105 into cosine of 45 plus 60. And it doesn't matter the order. You could put the 60 first, and there are other combinations you could use of angles on the circle that either add or subtract to make 105. Your final answer comes out the same no matter what. So now it becomes like the problems we just did. 45 is the alpha, 60 is the beta. Using the cosine formula will give us cosine 45, cosine 60, do the opposite sign, so minus sine 45, sine 60. Then go to the circle, square root of 2 over 2 times a half minus square root of 2 over 2 times square root of 3 over 2. So I'm going to skip a step and put all this together in one fraction. That's going to be square root of 2 minus square root of 6 all over 4. The sine of 15 degrees. There are several combinations of angles on the unit circle that we can subtract to equal 15 degrees. I'm going to use 45 minus 30. So the sine of 45 minus 30, and 45 would be alpha, 30 beta. Following the sine formula, sine 45, cosine 30, keep the same, cosine 45, sine 30. Then going to the circle, sine of 45, square root of 2 over 2, and so on. Square root of 3 over 2 minus square root of 2 over 2 times a half. All together then, we would end up with the square root of 6 minus the square root of 2 all over 4. The tangent of 75 degrees. An easy way to get 75 would be to add 45 and 30. So we'll do the tangent of 45 plus 30. 45 alpha, 30 beta. Again, those could be swapped. You could have the 30 first and then the 45, or two different angles to get 75. The tangent formula says tangent 45 plus, keep the sign the same, tangent 30 over 1, change the sign, so minus tangent 45, tangent 30. On the top we have 1 plus the square root of 3 over 3. On the bottom we have 1 minus 1 times square root of 3 over 3. So 1 plus square root of 3 over 3 over 1 minus square root of 3 over 3. So this is kind of messy. These are fractions over fractions. We need to simplify that. Remember the fraction bar means divide. So let's unstack this fraction. 1 plus the square root of 3 over 3 divided by 1 minus the square root of 3 over 3. Here I have a little addition problem I need to do and a little subtraction problem I need to do. These are grouped together because all of the first part was on top, all the second part was on the bottom. So I need a common denominator to combine these fractions. It would be 3. So if I put a 3 on the bottom, I also have to put a 3 on the top. That gives me 3 plus the square root of 3 over 3 divided by, same thing on this second one. If I put a 3 on the bottom, I have to put a 3 on the top. 3 minus the square root of 3 over 3. Then the rule for dividing fractions is to flip the second one and multiply. Now the 3's can cancel. And on top, I end up with 3 plus the square root of 3. On the bottom, I end up with 3 minus square root of 3. There's nothing there that you could mark out. It has to be all or nothing, and so that is as far as you can go unless you want to get rid of the square root in the bottom, but it's fine with me if you don't.